Number 8, we have an airline pilot that is passing over the top of a vertical loop. All right, so a loop-to-loop maneuver means she's going to go around like this and around like this. All right, at the top of her loop, she experiences weightlessness, which means, translated, that the airplane itself and she are both in a state of common free fall. In other words, that she's experiencing no force due to the plane. There's no normal force of the seat acting on her as it would be in any other part of the loop. All right, so that means that the only force acting on her at the top is her weight. All right, so now what we'll do is, we've done problems like this before. Net force is equal to mv squared over r. That's the centripetal force requirement. We also know from our free body diagram, taking the center of the circle to be the positive direction, right? So we get a positive mv squared over r. Net force is also just equal to mg. All right, taking those and putting them together, we just get that v squared over r is equal to g. I've already canceled out the m's. From that, we find out that the radius of the loop, because we are given the speed. All right, so if we're given the speed and we know what g is, the radius of the loop, r is just going to be equal to v squared over g. Meters squared per second squared divided by meters per second squared gives us meters. That's pretty easy. And so the radius of the loop is going to be equal to 200 meters per second squared divided by 9.8 meters per second squared is equal to, comes out to be 40814.081 meters for the sake of significant figures. Any chemistry teachers watching videos, we're going to get, we probably should call it, how about 4.1 times 10 to the 3 meters, or that's just going to be equal to 4.1 kilometers. That's a pretty big loop.